Hi everyone. In this lesson we're going to prove that two triangles are congruent using the hypotenuse-leg triangle congruence criteria. And this criteria is very important in that it only applies to right triangles. So it says hypotenuse-leg criteria for congruence of right triangles, only for right triangles. You cannot apply it to any other type of triangle. So we're going to briefly review what a right triangle is, and I have it right here. What is a right triangle to start with? What does the definition say? The definition says a right triangle is a triangle that has a right angle. So if it has a right angle, then it is a right triangle. So if you want to show, which you're going to have to do in these proofs, you are going to show that you have a right triangle first. So you are going to show that you have a right triangle by showing that it has a right angle. So if it has a right angle, then it is a right triangle, and the longest side, which in this case would be this one, or the side in front of the right angle, that is the hypotenuse, which is also the longest side. And the other two sides, the sides that form the right angle, those are called the legs. So those are the parts that we need to know. What's the hypotenuse? You need to be able to identify what's the hypotenuse and what are the legs. So the legs are very easy to identify. Those are the ones that form the right angle. And the hypotenuse is in front of the right angle, or it's simply the longest side. So let's look at what the criteria says. And it's called hypotenuse-leg, and I think by now you should kind of guess what are the requirements for this criteria. But let's read. If the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and leg of a second right triangle, then the two triangles are congruent. So you need two things only. You need the hypotenuse and a leg, and that's why the name is hypotenuse-leg. But it has to be a right angle. It cannot be just any, so it has to be a right triangle. It cannot be just any type of triangle. It must be a right triangle. So you need three things. You need first of all the triangles to be right triangles, and you get that by having one right angle. And then you need the hypotenuse, which is the longest side, and one of the legs, either one of them. But of course, if you have the long leg here, it has to be the corresponding one on the other triangle. Or if you have the short leg here, the small leg, then it has to be the small leg on the other triangle as well. So you need hypotenuse, one of the legs, and it has to be a right triangle. So I have some information here, very important. It says to use the hypotenuse-leg criteria, you first you need to show that you have right triangles. And how do we show that? By showing that the triangles have a right angle. First we do this, and then we use hypotenuse-leg. So first, show that you have right triangles by showing that the triangles have a right angle, because that is what the definition of the right triangle says. It says that a right triangle is a triangle with a right angle. So if you want to show that the triangle is a right triangle, you have to show that there is a right angle, that it has a right angle. So we're going to do, as always, or I'm going to do one of these problems. This is proof number one, and as always, I have four proofs over here. I'm going to do number one, and then proofs 2, 3, and 4 are your homework. So the instructions, one more time, say, write a clear and organized two-column proof using the hypotenuse-leg criteria for triangle congruence. So it says, number one, given AD is perpendicular to BD, BD is perpendicular to BC, and AV is congruent to CD, prove that triangle AVD is congruent to triangle CDB. So notice that here I'm just proving that the triangles are congruent. I'm not proving that sides are congruent or angles are congruent for which you need CP/CTC. You could do that in these types of proofs also. I'm just not going that step beyond. I'm just staying with congruent triangles. And that's how all your proofs are going to be here. You also have to prove that you have two congruent triangles. You don't have to use CP/CTC, but you could use CP/CTC with these proofs as well. I'm just not asking you to do that. So let's start by examining what we have. We have that AD is perpendicular to BD. And what we get when we have perpendicular lines or perpendicular segments, we get right angles because that's what the definition of perpendicular lines say. So because of that definition, I know that here I have a right angle. And then it says that BD is perpendicular to BC. So one more time, because of the definition of perpendicular lines, I know that here I have a right angle. So now that I have a right angle in each of these triangles, I can actually state that these two triangles are right triangles. So notice what we are going to have here. We're going to put these two givens in one statement. We're going to say given. And then from that, we're going to get these two right angles in number 2. And in number 3, because we have right angles, we're going to say that these triangles are right triangles because you need to show that the triangles are right triangles before using hypotenuse-leg. So now that we have proved up to number 3 that we have right triangles, we can show that it has a hypotenuse and a leg congruent in each triangle. So now, where's the hypotenuse? The hypotenuse is the side that is in front of the right angle, or the longest side, which is this one and this one. So AV needs to be congruent to DC, but actually that's one of the givens. AV is congruent to CD, so that's one of the givens. So this is the hypotenuse already. And now we need one of the legs to be congruent in each triangle, but it happens that these two triangles share the same leg, the long leg, which is BD. So by the reflexive property, because both of them share the same side, which is one of the legs, we have leg now. So this is right triangles with the perpendicular lines, we get right angles, which help us to conclude that these two are right triangles. And then the hypotenuse are given that they are congruent, and the leg is shared by both of them, so we have hypotenuse-leg. And so we are ready to make the conclusion that these two right triangles are congruent. So let's start by writing the givens in the same order as we did in the plan. So AD is perpendicular to BD, and BD is perpendicular to BC. That's given. And then from these perpendicular lines, we got that angle, this angle here, which is angle ADC, is a right angle, and also angle CBD is also a right angle. So we're going to say angle ADC and angle there was angle ADB. So here it's B. So angle ADB and angle CVD are right angles. And why do we say that we have right angles? Is because what we have in the previous statement, because we have perpendicular lines. The definition of perpendicular lines give us right angles. So that's our recent definition of perpendicular lines. And now that we have a right angle in each triangle, we're going to say now that these triangles are right triangles. So triangle ABD and triangle CDB are right triangles. How do we know this? Is because of what we have in the previous statement, which is that there is a right angle in each one. So by the definition of right triangle, we know that we have two right triangles here. So then, now that we have shown that we have right triangles, we can now mention the hypotenuse and leg. So the hypotenuse, remember that was given to us. So it's AB congruent to CD. Notice that we're mentioning in different order. We start up here, AB, and what corresponds to A in the other triangle is what's all the way in the bottom, because this is a rotation. So it's CD. So AB congruent to CD, and this is the hypotenuse. And the hypotenuse are two segments, and we have segments being congruent. So we have that, and the reason for having that is because we were given that. And then we're going to mention now the leg, and the leg is BD, but since this is a rotation, also we have to exchange the order of the letters. Let's say if we say BD for the triangle on the top, BD, then we have to say DB for the triangle on the bottom, because B on the triangle on the top corresponds to D for the triangle on the bottom. So it is the same one, but we have to name based on the correspondence. So this is by the reflexive property. And so now that we have three things: right triangle, hypotenuse, and leg, now we conclude that these two triangles, these two right triangles, are congruent by hypotenuse-leg. So we have now that triangle AVD is congruent to triangle CDB by the hypotenuse-leg criteria. And so that was the end of our proof. We don't have to go beyond that, but remember that you could go beyond that. You could, for example, show that BC is congruent to AD by CPCTC, or that angle A is congruent to angle C by CPCTC, and so on. But we are not doing that. We were not asked to do that. So that's the end of this proof. And let's just take a look at the following proofs very quickly. So here we have, again, perpendicular lines. So PA is perpendicular to AR, so you're going to have a right angle here. PV is perpendicular to BR, so you have another right angle here. So because you have these right angles, you will conclude that you have right triangles. And then you have to show the hypotenuse and the leg. The hypotenuse would be in front of the right angle. If the right angle is here, the hypotenuse would be PR, but PR is actually shared by both triangles, so you already have the hypotenuse on each triangle being congruent. And one of the legs is given to you. AR is congruent to BR, that's given. And so you have right triangles, hypotenuse, one of the legs, and so you should be ready to make your conclusion. The other proofs are similar. You're only using hypotenuse-leg in these proofs. You have, again, perpendicular lines, which should allow you to get two right triangles, and therefore you have perpendicular lines, which should allow you to get right angles, and therefore right triangles. And then you have RU congruent to SU, and then U is the midpoint of VT. And in the other one, this one looks like similar to one of the proofs that we did on the last lesson, or you had for homework, I think, but it's not the same because it has been modified so that you can use hypotenuse-leg. So you again have perpendicular lines, which should give you right angles, and therefore right triangles. You have one side being shared, and you have a given here of two sides being congruent. Okay, so let me just go back to the proof that we just finished. And previously in the other proofs, we used to get right angles and then say next that these angles are congruent because they are right angles, because there is a theorem that says that. But here we're not doing that. We're not we're not stating that we have right angles in order to say that the angles are congruent. We're not doing that because that is not what we need here. We don't need to show that we have two congruent angles. So the objective of showing the right angles here is to show that we have right triangles, not to show that angles are congruent. So be careful with that. And that will be it for today's lesson on how to prove that two right triangles are congruent using the hypotenuse-leg congruence criteria.